In this video, I'll go through how to factorize these cubics when they're in the format where both terms are cubed. So they lend themselves to using these two formulas, which you'll get on your formula sheet. I won't do every question. I just did that and I lost the video and it took 40 minutes. So I might just do 2 or 3 of these and see how you go. So I'll try and pick ones that are representative of the sorts of questions that you're going to get. The first one here is great. We can see here that both terms are cubed, and most importantly, it's positive. So I'm going to choose this formula here. If it was negative, like question D down here, I would use the other formula because of this little negative symbol right here. So what we do is we'll start out by writing out the formula that we're going to use. X plus y times x squared minus xy plus y squared. This first term will be my x value, and this second term will be my y. So anytime I see an x, I'll replace it with a c, and every time I see a y, I'll change it to a 3. So let's fill it out. We've got c plus 3, and I've got c squared minus 3c's plus 3 squared. Just highlighting here, as we go through the harder questions, you'll see that it doesn't matter what order you write the y and the x in here. It's often actually helpful to put the y before the x, because when they get more complicated, it helps you to expand the brackets. But you'll see what I mean in the next question with that. All right, let's keep going. We'll tidy it up as much as we can. There's a little bit of work to do in this one. Can't do anything with the c squared. The minus 3c stays the same, but we can turn 3 squared into a 9, and that's done. This is my final answer. Moving on. Okay, this one's positive as well, so fantastic. We can use the same formula. Ooh, drop my y. And so what we need to do is work out our x and y value. This one here will be my x, sorry. And this one here will be my y, but it needs some modification. This is better written now as 2x cubed, okay? Because everything has to be cubed for it to be subbed in. So if you're wondering how I turned an 8 into a 2, I did the cubic root of it. Let's put these into the formula. Every time I see an x now, I'm going to replace it with x minus c. And every time I see a y, I'm going to replace it with 2x. So this will read x minus c plus 2x. And over here, I'll have x minus c all squared minus, and this is the bit where I do the y times x rather than x times y, because 2x outside of x minus c is much easier for us to process than the other way around. It's the way that we're used to seeing it. And then on the end, we will square y, so it will be 2x all squared. Okay, let's clean it up. We can collect some like terms in that first set of brackets there. And in the second, we'll start to expand these out. So I've got, remember that this here, okay, means x minus c times x minus c. So we're back to expanding. So we're going x times x makes x squared, x times minus c makes minus cx, minus c times x makes minus cx, and then minus c times minus c makes positive c squared. Now I'm up to this part. Minus 2x times x makes minus 2x squared. And minus 2x times minus c makes positive 2cx's. And then on the end there, I've got 2x squared, which makes 4x squared. Remember that little indice applies to both 2 and the x. All right, let's clean it up. Now, how many x squareds have I got? I've got 1 minus 2 plus 4. So I've got 3x squareds. Then my cx's, I've got 1 minus 1 plus 2, so they cancel each other out. and I've got a little c squared there by itself. So this is fully factorized. Let's do question E. This one's also plus. So that means that we will be using the same formula again. And let's have a look. We've got a good x value, but our y value is not so good. We have to change that to 5w cubed. Again, to turn that 125 into 5, I did the cubic root of it, because everything in that term needs to be under the cubed sign for it to be able to be subbed into this formula. So we're just manipulating it a bit. All right, let's sub in. Every time I see an x, I'm going to write 4c minus w, and every time I see a y, I'm going to change that to a 5w. So that's x squared. Again, I'm going to put the y before the x here, just a bit easier. And on the end here, we've got 5w squared. Okay, in this one we've got 4 c's, and now we have 4 w's. And if we expand this out, we got 16 c squareds minus 4 cw's minus 4 cw's plus w squared. I'm up to here now, okay? Minus 5w times 4c makes minus 20 cw's. And minus 5w times minus w makes positive 5w squared. And on the end here, I've got 25w squared. Let's collect our like terms. I've got 4 c's and 4 w's. Now I'm up to my c squareds. I've got 16 of those. CW's, I've got minus 4 makes minus 8, minus another 20 makes minus 28 CW's, and I have got 1 plus 5 plus 25, 31 W squareds. And that's fully factorized. In the next page, question 1 and 2 are really similar. They want to see if something's a factor, and then they want you to fully factorize. So what I might do is I might do the first one by long division, this one here, and then I'll jump down and do this one by synthetic. So you got an example of both. But it's a good idea to test using the remainder theorem first. It's a little faster. So if we have a look at the remainder theorem, what we might do is we'll write this out like this. Oops. Like this. And then every time we see an x value, because this is a positive 2, we'll just put in a minus 2. Put that in your calculator, and you'll find out that equals 0, which means there's no remainder. So yes, this is a factor. And now we need to fully factorize it. I haven't left myself much room here, but we'll give it a go. Let's do this one using long division, okay? So what we're going to do is we're going to say, is x plus 2 a factor of x cubed plus 7x squared plus 14x plus 8. How many times is x going to x cubed? It goes in x squared times. X squared times x makes x cubed, but we're going to reverse the symbol. We want the difference between them. X squared times 2 makes 2x squared, so we're going to make it minus 2x squared. Let's work out the difference. X cubed minus x cubed makes nothing. 7 minus 2 makes 5x squareds. Grab the next term and bring it down. Start all over again. How many times does x go into 5x squared? It goes in 5x times. 5x times x, we're going to make minus 5x squared. 5x times 2 makes 10, so we're going to make minus 10x's. 5x squared minus 5x squared makes nothing, and 14x minus 10x makes 4x's. Grab the next term and bring it down. Start all over again. How many times does x go into 4x? It goes in 4 times. 4x times x makes 4x, so we'll say minus 4x. 4x times 2 makes 8, so we'll say minus 8. 4x minus 4x makes nothing. 8 minus 8 makes nothing. The remainder is nothing, which is fantastic, as we would have expected. And then when we go to factorize this, what we'll do is we will take this piece of information and this piece of information. So it will be x plus 2. I'm just going to cross this out so it doesn't confuse anyone. It's got nothing to do with that. And x squared plus 5x plus 4. Okay, that's factorized, but it's not fully factorized. Just ignore that x plus 2 for a minute. It just sits out the front. And what we want here is we want a double set of brackets like this. So, what are the factors of 4 that make 5? They are 1 and 4. So we will do, and this one is a positive, so they're both the same. This one's positive, so they're both positive. So we'll say 1 and 4. And now that is fully factorized. Question 2. What we'll do here is we will use the remainder theorem again. So we'll set that up here. We've got P with an X, and then it'll be x cubed minus x squared minus 5 times x minus 3. But this time when we fill it in, we've got a minus 3. So we're going to make this positive. Positive 3, positive 3, positive 3, positive 3. We'll put that in our calculator. And we'll find that equals 0. So there's no remainder. That is a factor. So let's factorize it. But this time we'll use synthetic division instead. Alright, we're going to set ourselves up for our synthetic division. So we'll draw in here. And what we'll do is we will have a look up here. We've got a minus 3, so we're going to make that a positive 3 here. And then what we're doing is we are stopping again, and we're going to cut in a second. Okay, let's set ourselves up for our synthetic division. I'm looking at this. It's a negative 3, so this one's going to be a positive 3. And then I'm having a look at my coefficients. So I've got a coefficient of 1, coefficient of minus 1, a coefficient of minus 5, and a constant on the end of minus 3. And so I'm going to write them in as I see them, making sure that I give myself plenty of space to work. And I'm going to grab that 1 and bring it down and begin. 3 times 1 is 3. Minus 1 plus 3 is 2. 3 times 2 is 6. Minus 5 plus 6 is 1. 3 times 1 is 3. And minus 3 plus 3 is nothing. The remainder of nothing. Excellent. Now we just need to factorize. So again, just like before, we take this here and this information here. We started off with our x minus 3, and then we fill in our gaps. I've got 1 x squared, and that came from here. Then I've got positive 2 x's, which came from this number, and I've got 1 on the end. It's not fully factorized yet. Fully factorized will be like this. And I can see here, what are the factors of the 1 that make 2? Well, that's going to be 1 and 1. So we can write it like this, or we can write it like this. And we're fully factorized. Let's have a look at expanding some of these. Unfortunately, with these, there's not really a fast way to do this. So what we might do is we'll just drop this one. It's a good example, this one. We can sort of speed this one up a bit at least. This one, we're having a look at this portion here. So I've just let this roll straight down here, and I'm ignoring it for the meantime. Now I've got 4x squared. So it's 2x times 2x. And we can see here from this plus and minus that these guys are going to eliminate each other. So we can skip the step that I'm about to do, but just so that it's nice and clear, we might be going minus 6x plus 6x. So we can see those guys will cancel. And then we've got 3 times minus 3 makes minus 9. And then we just tidy it up. Okay. And then what we need to do, of course, is we need to finish expanding this. So now it's x times 4x squared makes 4x cubed. X times minus 9 makes minus 9x. Minus 4 times 4x squared makes minus 16x squared. And minus 4 times 9 makes 36. In this second one, there's a couple of ways of doing this. I'll show you a way that's probably not the fastest way to do this, but it's fairly bomb-proof. The answer sheet for this is got an alternate way of looking at it. So let's just have a look at it if we do it this way. If we do it the long way, really what we're looking at here is 3x minus 1 times 3x minus 1 times 3x minus 1. And so what I'll do is I'll just drop this first portion of the equation down here, and then we'll deal with the second bit. So we're going 3x times 3x makes 9x squared minus 3x minus 3x plus 1, which means we'd end up with minus 2, 3x minus 1. And then if we tidy this up, alrighty, let's now work on dropping that 2 there and then tidying up what else we've got. So we've got 3x times 9x squared gives me 27x cubed. We've got 3x times minus 6x gives me minus 18x squared. And then we've got 3x times 1 gives me 3x. Then we got minus 1 times 9x squared gives me minus 9x squared. And then we've got minus 1 times minus 6x makes positive 6x. Then we've got minus 1 times 1 makes minus 1. Then what we're going to do is collect some like terms, and then we'll deal with that too. So here we go. 27x cubes. We have got minus 18 minus 9x squared. So we've got minus 27x squareds. And then we've got 3x's plus 6x's makes 9x's. And we got a minus 1 on the end there. And now we've just got to go through and times everything by negative 2. So we've got minus 54. Funny looking for x cubes. And then we've got plus 54 x squareds. And then we got negative 18 x's. And we got positive 2. And then that one's fully expanded. Now let's see what happens when we've got a polynomial that we're told can be divided by x plus 3. So here's our polynomial here. We're told it can be divided by x plus 3, but what we're trying to find is a random value in here, which in this case is a. So what we'll do is we'll start by replacing all of our x's in this first equation with minus 3, the opposite to the plus 3 here. So we'll put those in. And now what we'll do is we'll solve it. So this would give us negative 27. And then here we've got 9a's. And here we've got 24. And here we've got 12 on the end. So now we've got minus 27 plus 24 makes minus 3. Minus 3 plus 12 makes 9. And 9a. Balance method. Just take 9 from both sides. Divide by 9 both sides. Oops. And we'll find that a is minus 1.